Hey guys, in this video I will be going over the most difficult questions from the Unit 4 mid-unit test. This was a difficult test, but based on the average, probably the most difficult test of the semester thus far. And I agree, it is kind of a difficult unit. There's a fair amount of problems to solve and some critical thinking questions. And so hopefully I'm going to go over 5 or 6 of the most difficult questions for this, so pay close attention because you'll obviously see these again on the retake. And remember, at the end of the video you'll receive the password to retake the test to make sure you write it down, and then you'll be able to do that from now all through spring break, and then I'll probably take it down on the Monday or Tuesday after spring break. So let's look at the first question. This was the first one on top here. This question was the most difficult question on the exam. In fact, most of these we'll go over. Under 30% of the people got them correct. Only 17% of students given this question on top here got it correct. So air flows. This is the wind the wind flow question that we did in class. Air flows according to differences in thermal energy, and we know it goes from air flows or heat flows from hot to cold or warm to cool, right? So heat flows, we'll say hot to cold. Heat always flows from areas of warmth or higher thermal energy to areas of cold or lower thermal energy. So we're given if a warm air mass is located in southwest US and a cold air mass is in the southeast, this is important to remember, from which direction will the winds blow? And so let's draw the United States here again. Let's see, here's the Gulf of Mexico and Florida. There's Maine, and then, okay, there's the United States. So we have warm air, warm air in the southwest. Okay, so here's our warm air. Cold air mass is in the southeast. Okay, yep, southeast, cold over here. And now from which direction will the winds blow? And you're given west, north, south, and east. So if this helps on a question like this on the test, draw out the map, draw your warm air masses, and then draw an arrow showing which direction the wind's going to blow. Okay, so I know it's going to go from hot to cold. It's going to start over here in the warm, and it's going to go this way. So it's saying from which direction. That's asking where does it start? From which direction does it start at, and which does it blow to would be finish. So it says from, so I know it's starting in the west, right? It's going from the west, because this is the direction west, to the east, and then we have north and south. Right, so it's going from west to east. It's not, the most common answer was east. It is not going from the east to the west. That would be going from cold to warm. We're going from warm in the west, so it's starting from the west to the east, to the cold. Okay, next question. In a calorimeter, the temperature of 100 degrees of water decreased by 10 degrees Celsius when 10 grams of ice melted. How much heat was absorbed by the ice? This question is difficult because you have a little bit of extra information and you need to decide what is important. And we need to look, I think hopefully everyone knows or used this equation, the specific heat equation, C equals Q M delta T. That's used a lot on this exam, that delta heat equation. And so just like normal when we're using this equation, we know 3 variables and we're just solving for the variable that we don't know. And the tricky part here is you have to know whether to use 100 grams or 10 grams for your mass. But since we say the question says the temperature of the water decreased by 10 degrees, then I want to use the mass of the water. Right? We're not talking about the temperature of the ice decreasing. It says the temperature of the water decreased by 10 degrees, so I need to use this mass. So there's our mass. Change in temperature is right there. And then it's asking for how much heat. Remember, the variable for heat is Q. So we're solving for Q. And then I can get my specific heat, remember, from this table. This table here, when you see these tables, these are all specific heats. And so that's going to equal, it tells you right here, actually, the variable C. And so I look for, and remember I'm using water. Again, we're talking about water, so I'm not using the ice one. I'm using the one for liquid water. So there's my C. And now I can just put those in the equation. 4.18 equals, remember it's asking me for Q, divided by 100 grams is my mass, and then 10 degrees is my temperature. Now you can do this all in one step. You basically, when you're solving for Q, you just multiply those three numbers together. If it's easier for you to do it stepwise, then you can definitely do that also. So stepwise, I would do the bottom first. 100 times 10 equals 1,000. So now I'll rewrite my equation over here. 1,000. Now I need to get Q by itself, and so I multiply each side by 1,000. Cancels. 1,000 times 4.18. We'll write it down here. Is 4,180. And remember, we're in joules right now because we have joules here. But the answer, the second tricky part of this question, is that it asks you for the answer in kilojoules. Oh no, what to do? We need to convert our joules to kilojoules, and we can do that with a simple conversion. Remember, 1 kilojoule equals 1,000 joules, and hopefully you're realizing kilo means 1,000, so a kilo of anything is 1,000 of that. So a kilojoule is 1,000 joules. And then I solve for this, multiply across the top, multiply across the bottom, and so it ends up being 4,180 divided by 1,000 equals 4.18 kilojoules. And that is our answer. So two kind of tricky parts in there. You need to know which mass to use, and then you need to convert from joules to kilojoules. All right, down here we have our phase transition diagram, and hopefully this is, you guys understand this a little bit more now after our class Connect yesterday on Thursday. However, we need to look here, and we're looking for the letter that represents the transition from the important part here, solid to liquid. So where in this graph are we going from solid to liquid? And remember, that point on the graph is, on this graph is right here. Right here. Where we're going from kind of the transition from A to B, and so this whole line here, this is the area where we're transitioning from solid to liquid. So if you're thinking about, maybe we're thinking about ice, if this is water we're looking at, it's ice here. And then right here, the B, on B, this line, this horizontal line, is the period of time when the ice is melting. It's the amount of heat that's melting the ice. All right, so B is our answer. A lot of people put C. A lot of people thought it was C, and that's not correct, right? We've already melted at C. Now we're in liquid water. This is where we're in liquid. Right? We're heating up our water. And then D is where it's boiling. It's changing to steam. And then E, we're at water vapor. We're at steam already. All right? So we're at solid ice on A. On the B line here is when the ice is melting. It's when the ice is melting at 0 degrees. And then we're heating up the liquid till we get to 100 degrees. Remember, this is Celsius, so that's the boiling point. Now we're boiling. And then boiling, you see the steam rising. And then so once we've boiled all the water, then the temperature continues to rise in steam. So which letter is the transition from ice to liquid water? It would be B when it's melting. Next one, how much heat is needed to raise the temperature of 50 grams of a substance by 15 degrees Celsius when the specific heat is that. And this one I was a little bit disappointed in because there's not really any trick to this one. It's just plugging numbers into the specific heat equation and then solving. So this one, our specific heat equation again, is this. Now we're looking at our question. And if it's helpful, guys, I would write these down. Write down the variables on a piece of paper. So when you're reading a question like this, go through and say, okay, 50 grams. M equals 50 grams. There's my mass. Of a substance by 15 degrees Celsius. I know that's it. It changes. Change in temperature equals 15 degrees C. And then when my specific heat is this, and so C is the specific heat, 0.92. Write out all the units here. Okay, so now I've written out my variables, so what's the only one that I don't have? Oh, I don't have Q, and that is what the question is asking. It's saying how much heat is needed, and remember Q is the variable for heat. So now I just plug these in again. This is very similar to what we did above. This one's actually simpler though because there's not extra information and you do not have to convert in this one. Q, and then our mass is 50. Change in temperature is 15. So again, you can multiply these three numbers to solve for Q. And if you forgot how to do, or you can solve it the other way, I'm not going to do that because I went through those steps up there. It's the same steps. So 50 times 15 times 0.92 equals, Q will equal 690 joules. And I know it's joules because here in our specific heat it's given in joules. And then we look at our answer, and the answers were given on the test. All the multiple choice answers are already in joules, so we do not need to convert. The answer is just 690 joules. All right, and then the last one I want to go over is this. It's basically an endothermic versus an exothermic reaction. And this one I was also kind of surprised at. Only 35, and we're still only up to 35% of people are getting these correct. Only 35% of people got this one correct. And it's asking us to identify an endothermic reaction. So the first thing you need to know is what an endothermic reaction is, as opposed to an exothermic reaction. Remember, an endothermic reaction, think of enter, heat is entering the system from the outside world, so things feel colder. Right, if we have an exothermic reaction, things feel warmer. It's releasing heat. Remember, endothermic is absorbing, exothermic, heat is exiting, heat is being released, so it's going to feel hotter, right? And it's asking you to identify an endothermic process. And you're given three things: a nail rusting, a cold pack cooling, a mix of acid and a base, and a heat pack. And so you guys, basically, people chose either the cold pack or the heat pack. And a lot more people chose the heat pack. But now, since we know this, exothermic, remember, releases heat, then a heat pack would be an exothermic reaction, not an endothermic reaction, right? A cold pack. Hopefully we saw this coming after that explanation. The cold pack is an endothermic reaction. It's absorbing heat from its surroundings, so it feels cold. If you put a cold pack on your sore shoulder, it's absorbing heat from your shoulder, and so your shoulder feels cold. Right? A heat pack would be exothermic reaction. It's releasing heat, right? You put a heat pack on your shoulder feels hot because it's releasing heat. So endothermic feels cold, so the cold pack is our endothermic reaction. All right, guys, hope that helped. Remember to write down the password coming up here at the end of the video, and good luck on your retake.